Here's what we'll build today: a complete process tank with valves and level instrumentation in AutoCAD Plant 3D. Today we'll design a small cylindrical vessel with 4 round legs. It may not look very exciting, but industrial plants couldn't survive without equipment like this. Its geometric volume is 1.25 cubic meters, while the working volume is approximately 1 cubic meter. Here you can quickly verify the tank volume using a free online calculator. It's a very handy tool for checking your design. To achieve a geometric volume of 1.25 cubic meters, we could either increase the diameter or the height. I prefer keeping the diameter at 1 meter because it's a common standard size that simplifies fabrication, transportation, and future equipment selection. So I'll increase the vessel height instead. Let's assume that about 80% of the vessel volume will be used as working volume. That means the geometric volume needs to be larger than the required working volume. So if we need around 1 cubic meter of working volume, the vessel should have about 1.25 cubic meters of geometric volume. With a 1 meter diameter, that gives us a vessel height of roughly 1.6 meters. Now let's add the nozzles very quickly and keep it simple. On the top of the vessel, I'll add a vent nozzle and an inlet nozzle. The vent allows air to escape while the tank is being filled, and the inlet is where the liquid enters the vessel. On the side, I'll add 2 level instrument nozzles. One is for the high-level signal, which means the tank is full and it's time to stop filling or start emptying. The second one is for the high level alarm, which is an emergency signal indicating that the tank is overfilled. I'm measuring this distance now, and I'll explain why it matters in a moment. I'll rotate one of the nozzles by 15 degrees to create more space for the level sensor heads. Small adjustments like this can make the final installation much cleaner and easier to maintain. Near the lower side of the vessel, I'll add the outlet nozzle for normal operation. I'll position the outlet nozzle slightly above the bottom to reduce the chance of debris entering the outlet line. At the bottom, I'll add a drain nozzle so the vessel can be emptied completely. Now let's quickly add the remaining components to all the nozzles, so it's easier to understand what each nozzle is used for. I'll finish the vent with a simple gooseneck. It prevents rain and debris from entering the vessel while still allowing it to breathe. I'll move the inlet nozzle to the side. The drain nozzle assembly is also from 3dfindit.com. It's a very simple model, but it looks clean and works perfectly for this type of vessel. Now I'm adding a flange and a short pipe section. The outlet valve is very similar to the drain valve. The only difference is that it has a larger diameter to handle the normal process flow. Don't skimp on pipe supports. This valve is relatively heavy, and without proper support, its weight can put unnecessary stress on the nozzle. I downloaded these level sensors from 3dfindit.com. They're fork-type level switches, one of the most common point level sensors used in industry. They detect when the liquid reaches a specific level and send a switching signal. I'm not going to spend time searching for the exact level switch model. I'll simply use a fork-type level switch to visualize how the final assembly will look. The idea is not to make the level nozzle too small. The fork of the level switch must physically fit through the connection. I checked this with an automation colleague, and for this type of fork-level switch, the N50 is enough. Whether the connection is threaded or flanged is less important here. The main point is to provide enough opening for the instrument. Now I can explain why I measured the distance from the top earlier. On real vessels, the top and bottom sections are usually reinforced with stiffening rings. Because of that, you generally shouldn't place nozzles in those areas. That's why I left enough clearance from the top before positioning the level nozzles. I recently designed a very similar vessel for a real engineering project. Let me show you what I mean. Here's an example of a real vessel with stiffening rings near the top and bottom of the shell. Here's what a stiffening ring looks like on a real tank. And that's our vessel complete. Thanks for watching, and I'll see you in the next Plant 3D tutorial.